On the last slide for this lecture, we will derive expressions for the heat, Q, the change in enthalpy, delta H, the change in energy, delta U, and the work W for phase transitions. First, we need to remember that phase transitions occur at constant temperature and constant pressure. So the heat Q will be equal to the change in enthalpy for the phase change. The change in enthalpy will be easily calculated from delta transition H standard given in the text of any problem for 1 mole of substance. So we will write delta transition H equal number of moles times delta transition H standard. Remember to pay attention to the sign for delta transition H standard. Values of delta H transition standard are typically given for melting or fusion, not for freezing or crystallization. Similarly, values of delta H standard are given for boiling or vaporization, not for condensation. The change in energy, delta transition U, is equal to n times the standard delta transition U for 1 mole of substance. Again, n is the number of moles of substance in the system. Next, we use the relationship between H and U to get an expression for delta transition U standard. Recalling that H equals U plus PV, or U is equal to H minus PV, we write delta U standard as delta H standard minus delta of PV standard. Remember that standard implies 1 mole, so the change in volume in this equation is the change in molar volume between final and initial states for the phase transition. Since the pressure is constant and equal to the standard pressure, we obtain delta transition U equals n times, parenthesis, delta transition N standard minus P standard times the change in molar volume. You will generally be given sufficient information in the text of your problem to know the value of delta transition H standard. To calculate the change in molar volume, you will need to ask yourself in what phase the substance is at the end and at the beginning of the phase change, and use expressions for the molar volume that are appropriate. For liquids and solids, we write the molar volume in terms of m, the molar mass of the substance, and d, its density. For ideal gases, we express the molar volume as a function of the gas constant R, the absolute temperature T, and the pressure P. Note that you must use R equals 8.3145 joules per mole per Kelvin if you want to express the molar volume in meter cube per mole and the energy change in joule. Finally, to calculate the work, W, we will first calculate W0, the work for 1 mole of phase change, and then multiply W0 by N, the number of moles. The work for the phase change is the work associated with the change in volume of the system under constant external pressure, usually the standard pressure. So we write W as number of moles, N, times P standard times the change in molar volume between 1 mole in the final state, phase at the end of the phase transition, and 1 mole in the initial state, phase at the beginning of the phase transition. Again, pay attention to the nature of the phases in the initial and final states in your calculation of the molar volumes. When calculating the change in internal energy and the work, you should remember that liquids and solids occupy much less space than gases, about 1,000 times less or so. So it is totally appropriate to neglect the molar volume of the liquid or of the solid in comparison to that of the vapor. This will simplify your calculations for any phase change that involves the vapor phase.